So, okay, parametric equation. This is gonna take 11 or 12% in your ABSM. So you need to know this. Yeah.
To 12?
Yes. So that's take more portion than the limits and continuity. So we're gonna spend more time on here. Okay. Let's say this is a circle, right? Yeah.
No, I'm just kidding.
Is it a function?
No.
Well, for the circle, what is the equation for the circle? X squared plus y squared. Let's say this is the radius 1. Okay, equal to 1. Right? Now, this is the function, right? The function of circle. But when you represent into, they call Cartesian. Okay, Cartesian. So this is called Cartesian. Cartesian is x, y. You have x and y. The rectangle.
Is that an R?
Yeah, R C A R T E S I A N.
Sorry.
Cartesian. No worry. So why this one is the function? But if you draw like this, they're gonna fail what? They're gonna fail the horizontal is 1 to 1. They fail the vertical, right? So they fail the vertical. So if you're using a vertical lattice, that's not gonna work. They're not a function. Or even like this. If you have some, let's say, object, they go in like this, they go in like this. It can go like this. But if you draw the vertical lattice, they're not a function. So what is the way that you can represent this that is not violates the vertical lattice? So then we're gonna call a new letter. So a letter T. So you're gonna write it. No, letter doesn't matter. You can use any letter. But the point is parametric is you call another variable to represent x and represent y. So before, let me explain again. Before you're gonna use what? Y equal to fx, right? So that means x is dependent on y. So this is before. Okay. Now this today, parametric equation, you're not gonna use, so x and y are independent. But they're gonna use another variable to represent this. So we're gonna use x, y, or function of t. Yeah, that's today. So today, yeah, that's today. That's right. X and y are function of t. T, why they use t? Because sometimes t is for time. So if you give some, let me give you some real life application, like GPS. Okay, go like GPS application. Because you need to understand why we need to use this. Like GPS. Okay. So like GPS, at different times you're gonna have different longitude and latitude, right? Like t equals 0 here, t equals 1 here, t2 here, but t3 you can be here, and t4 you can be here, right? But because the time, so you need to have some arrow to show what is the way, right? It can be like this, right? It can be like this, different time. So this is t equal to 4, and then t equal to 5 is right here, t equal to 6 right here, t equal to 7 is right here. Right? So this is how the GPS works. Like how do you represent for the GPS? Then it's like different time, you have different location. You cannot represent something like this on here, on 2D. Not like really 2D, but on this side, only X and Y. But you need to call for the new new variable T. Okay? Alright. So let's rationale. Let's try so you understand why. So we cannot write. So this is your new concept, so we're gonna write so you can understand. So this curve, for example, this curve right here. Okay?
Why can't we write Y?
Huh?
Why can't we write Y?
Because you need two number for this one. One number is x and one number is y, right? So you already use x and y. Then how do you represent the time t? You need to call another t. So x will be a function of t. Y will be a function of t. Did I answer your question? Yeah? Okay. That's a very good question. Because every point here you need two number, right? Number x and number y. So every point here you need x and y already. And then chase the curve. And then how do you represent the time? That's why you need to call another variable t. Because x will be a function of t. At different t, you're going to have different x and y. Okay? At different time, you're going to have a different longitude and latitude. For example. Okay? So parameter t by writing y equal to ft and x equal to gt. Then each point, I'm going to write carefully because this is the first thing you see in this. You saw this. On the curve can be written as st, yt, or ft, gt. Okay, so that's the concept. We cannot write f equal to fx because again, if you do like that, you cannot represent the t, and you can also see that they all fail the vertical line test. So then, but we can change the curve. I'm talking about a curve like this. You see the curve, the pathway of the particle going or the object going, or if it is a GPS, the car going, right? They go like this. What about they go like this? So then you can change this one by using a parameter t. T is stand for time. You can think about time. For example, at the time 0, x at 0 is some number. Y of 0 is at some number. Right? At the time 1, x of 1 is some number. And y of 1 is some number. So that you can change around the curve. That's the purpose. Does it make sense?
So
When we work, yeah, question.
So the T is like the X or the Y? Or
X is a function of t. Y is a function of t. Not like before. Before, y is a function of x, right? You give me x, I give you back y. But now, not work anymore. If you give me x, I cannot give you y. But if you give me t, I can give you both x and y. Like if you give me a time, I can give you exactly what is the longitude, what is the latitude.
oh,
Make sense?
like the T. Okay, so the T.
Now do you think about this? Now the t is the x. T is the x before.
Yeah.
Yeah?
Yeah.
But now you have two functions, not just one function y, but now you have two functions x and y. You give me a t, I give you back x and y. Yeah? If you give me x, you ask me for y, maybe I can find it, but I convert them back to this. Convert them back to Cartesians. Okay? You need to convert. Today we're gonna do some conversion between Cartesian and parametric. We're gonna do both of them so you understand how it works. Okay? Are we good? Can I erase this? Okay. Let's do some example and then you understand how does it work. So literally we just create another variable so that we can change some curve that is need three parameters. The direction, x and y, and the time. Okay? Okay, let's do a sample. Or did you check the message, the two problem I gave you yesterday? Did you try it? Who tried? Okay, good. Who found the answer? Okay. At least you tried. So manually, let's do some manually one. Manually, that means you're gonna change the curve. Like how is it look like? By just plugging in different time to find where is the longitude and latitude. Like where is the x and where is the y. Okay. So that's how it works. T start from where? T start from -2. 2. Let's just write it all down. -2, -1, 0, 1, 2, 3, 4. Right? Now when you see the T, this one you can do calculator very easy. Just plug it into function and then you plug it in this table. You know how to use it? You know how you use a calculator when for the table?
No.
We can do maybe sometime. Like I make so many promises. So when you put function, you know how to use it one? Y equal to, and then you just type this t square minus 2t t plus 1, and then there's a table. Table set to push second window. Where is it? No, second wrap right here. They give the table, and then you just type -2, -1, 0, 1, 2, 3, 4, and they give you everything. That saves you a lot of time. We can practice together maybe tomorrow too. After numerology, we have time. But let's do 1, 2 line, and then I'll give you the rest. Okay? -2. When you plug it in, what is the x? -2 square is
4.
4. 4 minus 2 times -2 is
4.
0. I have some 0.
Oh, it's minus 4, no?
4 minus 2 times -2.
It's 4. It's minus 4. Like negative 4.
Not 0. Not 0. 8. 8. Negative and negative become positive. So 4 plus 4. Right? So 8. -2. Oh, easy. It is -1. Okay? So 8 and -1. 1, 2, 3, 4, 5, 6, 7, 9, 9. 1, 2, 3, 4, 5, 6, 7, 8. So 8 and -1. Right? And the next one, what is the next one? 1 plus 2, which is 3. So you know how to calculate this? So I'm gonna give you the whole thing. So if you plug it in everything, you see that everything depends on the t. X also depends on the t. Y also depends on the t. So when you have the t, you can find x and y. But if you know the x, you cannot tell the y like before. Okay? So after this, you want to plug it in to see how it look like. 3, 0 here, 0, 1 here, -1, 2 here, 0 and 3 here. All over the place, right? 3, 4, 1, 2, 3, 4. And then 1, 2, 3, 4. Why do I get this? -1 and 2, 0 and 3, oh, right here. 3 and 4, 8 and 5, 8 and 5. Okay. -1 and 2, so it should be here. Okay. So now you need to start from the order. Because remember, the curve, they need to go by order. So you need to put the arrow to see where it's going. Okay? Let's start from 8 and -1. So let's start from here. And then go here. So they're going to be look like this. They go here, they go here. Like this. Okay, so this way right here. You see, does it pass the vertical line test? No, right? So it's not an even function, but it is a function. It is the function. The function is this. Now you wanna wonder, this doesn't look like the one that we learned before, like Cartesian, right? So now there's a way to convert this whole thing here back to like Cartesian, like the one you learned before. So let's see how it looks like. Like if you want to write a function y in terms of x, how do you do that? If I want to eliminate the t, how do I do that? So finding Cartesian equation. So Cartesian means x and y only. Okay? Okay, finding Cartesian equation. That means you only want x and y only. So how do you eliminate the t? I know. How do you get rid? How do you get rid of it? Huh? How do you get rid of it? So we have xt equal to t squared minus 2t. Yt equal to t minus t plus 1. In what way you can like eliminate the t? So only have x and y now. That's showing the relationship between x and y. Yeah? Huh? Some people learn it like after a while. Yeah? Kind of close, yeah. No. Because when you set it to 0, no. That means you just find in what time the longitude and latitude is at 0. Yeah, that's what you're gonna do. Very good. Yes. So which one is easier? Is that you solving the t here easier or solving the t here easier? This one easier, right? So we're gonna take a look at this one. Okay. Do you agree that this one means t equal to y minus 1? Yeah. And then what we're gonna do? We're going to plug it in, substitute. So this one, I'm gonna plug it in into t. Okay. T here. So now I have x equal to xt equal to y minus 1 squared minus 2 times y minus 1. And now you just expand it, and that's it. That you have some function only x and y. Because when a function only has x and y, that is Cartesian. Okay? So y squared minus 2y plus 1. I hope everybody know how to do square of binomial. Yeah? A squared minus 2ab plus b squared. A squared minus 2ab, or 2ab is just 1. Plus b squared. 1 squared is 1. Okay? You should learn by this one. You should know why now. Okay? And if a plus b squared, you just need to change the bigger one. Okay? You should know why now. Alright. And then minus 2y plus 2. Simplify this, you have y squared minus 4y plus 3. And that is your function. Yeah? If you even want to look better, you can even factor it out. How do you factor this one? Your question? Question. Which one? Which one? Which one? Ask me. Yeah. Which one? This one? Oh yeah, I just move the y over here and move the 1 over here. Oh no, I keep the y but I move the 1 over here. So like I minus 1 both sides. Yeah. How do you factor this? 3, right? 2 number multiplied 3 is 3 and 1, and then it's negative 4, so minus 1 and y minus 3. That's another one. Yeah, question. Yeah.
Like I like down for like 5 seconds, but like and that was done, and like I kind of lost. So like
Just look down.
the
So don't look down anymore. Just run like this.
so like the XT equals Y minus one. Where how did it get there?
Oh, okay, because I'm bucketing this one, I'm bucketing this one into the t. Right? X equal to t squared.
Oh.
Oh yeah, but then t squared is 1 minus 1.
Oh.
Then I said I have this. Right? This whole thing is t. This one needed t. And this one needed t. Yeah? So that is condition. Condition question. Right? Now, do you realize they put you condition? They call restriction, right? The restriction is t needs to be from -2 to 4. So when you change your condition, you need to also show the restriction on x and y because they cannot be any number. Like t needs to be from -2 and 4. And x and y need to be from what number to what number? How do you find that? Find for me the restrictions of x and y. Because t needs to be between -2 and 4. There's some restriction, there's some bounded. Okay, there's a bound. X and y need to be bound as well. Need to be bounded as well. So how do you find it? Easy. Anyone?
Use the Y.
You're using what information? Yeah, Jake. Equal to 0. So think about this. X equal to this. Y equal to this. And you know that t is between this. Using the information, can you find for me what is y and what is x between? I'm gonna do some easy one. I'm gonna do this one first, okay? T between 4 and -2. What is t plus 1? Between pi and -1. Right? I add 1 to everything. I add 1, add 1, add 1. Yeah? I can do that? I can do that, yes.
But isn't it on the table?
You can also identify the longest, the largest number and the smallest number. I'm saying without the table. Like let's say they just ask you to find a Cartesian equation, then you don't want to like give the whole right. But even if like they can give you t from like 100 to 200, you're not gonna list the whole table, right? But that's a good one. Yeah. Now how do you find this one? So t, this one is y, right? Y between pi and between -1. Y between pi and -1. How about x? Find the x for me. Find the x for me. 1 minute. 1.5 minutes.
I don't know.
Got it? 8. 32? 8 is 32.
No.
8? Yeah, 8 is correct. But how about the other bound? 81, why? Because of the table? How you got that? 8 and -1. How you got that? Add 1 for y because y equals t plus 1. Right, so I'm gonna add a start on t. I add 1, so that it look like the y now. So basically you find what is the minimum value of this, right? Find the minimum value of this, and you find the minimum value. Okay, so when you find, now you have deja vu. I've seen that before, I got that before. When you find the minimum or maximum, again, taking the derivative, set up equal to 0 to find the critical point. After you find a critical point, you need to check if they on the interval. Okay. Now it's okay because they belong to this interval. We plug it back, you get -1. That is the minimum, right? You do the side chart. Do the side chart. The 1 is here. The leading coefficient is positive or negative? Positive. So after they pass the critical point, they become negative, right? So like this. So this is the minimum, right? So they're all connected. Everything you learn is connected. So that means when you got to this one, this right here is gonna give you the minimum, which is -1. So you count -1. I'm saying if you don't know how to do the table, but if you stuck, you don't want to think a lot like this, just do the all table. Just see what is the number is the largest, what is the number is the smallest, like Valeria says. Yeah, Valeria says. Yeah. Okay. What time we done for this period? 39. Oh, let's do the circle. How do you feel the parametric so far? Not too bad, right? It's just calling a new variable to that. Uh-huh. Yes. Oh, okay. 8. You know T from 4, right? So one way you can do it like this. T is from here, right? And then T minus 2 is from, so T is between 4 and -2. So T minus 2 is between 2 and -4, right? I minus 2 to both sides. I minus 2 to both sides, right? And now I'm going to multiply these two together. Notice that these two are positive, so you can multiply. But these two are negative. When you multiply, you're going to guess they're not correct. Remember when you multiply something negative, the sign going to be different. So this one you don't care. But this one, at least you know that t less than 4, t minus 2 less than 2. So when you multiply them, you know that t minus t times t minus 2 less than 8. So do everything that you can to get the value. You have not yet? Yeah. Hang in there. Hang in there. We still have one more year. The whole school year.
Can you just plug in the 4 into the equation of c?
What do you mean?
Like, you know how like 4 is like, I don't know if it's just a coincidence, but if you put 4 into the equation,
Oh, that worked too.
you
Yeah,
get
that
8.
worked too. Yeah. That worked too. Yes. You can plug it in 4. Then you already get 8. Yes, that's one. But I'm showing here. I'm showing like when you find a maximum minimum.
But does that show the
I get back to you. Yes, very good question. You can actually go from the condition into here. Yes. Actually, that one it will be on the same too. They're asking you to convert. They're asking you to convert between condition to polar. Polar mean circle, and vice versa. So yeah, that's a very good question. Yes. So let's do polar here. we go. Here we go, Jay. This example is the one that you asked. Yeah, this example is the one you asked. We're gonna go from here, go back to the. No, no, oh, no, 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 not yet, not yet. Okay, so where's the number? 0 to 2 pi. Let's use a beautiful number. Okay, t equal to 0. What is x? Let's use some just beautiful number like 0 pi over 6 pi over 3 pi over 2 pi pi over 4 pi over 3 pi over 2. It is circle.
Oh, like how do you know where? How do you know what
In table?
Yeah.
Oh, they say t between 0 and 2 pi, so I just pick random.
Oh,
I just pick random to see where it's going.
but like it comes from you, but there's no specific order.
Well, it just turned out this is a unit circle. It's so the order doesn't matter.
Oh.
But you need to sketch. Yeah, actually, the direction is order. It's
So we have to go on a certain direction.
yeah. You need to start from 0 all the way to I to 2 pi.
Okay.
Yeah. Huh? Uh, you pray again?
So you never taught us. You never taught us. You told us one day and brushed it and then.
Okay. So
Can we do
now,
a quick memorization?
so what do I promise you? Calculator, right? Using calculator.
Oh yeah,
What about I forget? And then unit circle,
Numerology.
numerology.
Numerology is our priority. But we're
Okay.
gonna start next week.
Tomorrow we're gonna do numerology and spell calculator. And then unit circle it is a lesson. Maybe Monday. It's on Monday. Okay. So when t equals to 0, when t equals to 0, what is x? Cosine 0 is 1. Oh, good, good. Sine 0 is 0. Cosine of pi over 6. Cosine of pi over 6. Oh, so you don't learn unit circle again in the AD campus.
No, he didn't go for it. Only because he trans on us. But I didn't like the
And I was only for like 3 days.
I need to refresh this.
It's like 12
One, two, three.
It was just like the same damn chart.
Yeah, he did it for like a full like.
Yeah, I just I really fucking
It was. I remember I liked it, but I actually knew what was going on.
This is cosine. Okay. This is sine. Alright? Unit circle, the way they call units, that means everything is 1 here. 1, 1, negative 1, negative 1.
It's
Okay?
negative one.
Yeah. Then in the year there's some special angles. This is the smallest one. This is special one. Which one is the smallest? Pi over 6, right?
Oh yeah.
The larger bottom, that means the smaller it is. Right? So pi over 6 here. What is the next smaller one? Pi over 4. Next one? Pi over 3. And this is the pi over 2, the 90 degree. Pi over 2 is 90 degree. Remember that pi is 180 degree, right? You know this, right? This is the radian, this is degree. So pi over 2 is 90 degrees. You just need to know this call. The rest is just symmetric. Okay? Now, to remember the, the value, it's easy. This is the largest number. Do you agree? This is second largest and this is largest, and this is 0, right? They have an order. Square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. They in order, right? Square root of 2 over 2 larger than square root of 2 over 2, right? And correspondingly, this is also in order. What number here? Same thing.
Oh.
Square root of 3 over 2, square root of 2 over 2, and square root of 1 over 2. Now, I write like this so you know that square root of 1, square root of 2, square root of 3. But what is square root of 1? It's just 1. Right? You don't need to write this. But I write it for you to see that they're in order. Right? So you don't need to write square root of 1. Yeah? That's the reason why cosine of pi over 3 is 1 half. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Yeah? So what's good? That's the reason why tangent of pi over 4 is. What is tangent of pi over 4? Well, tangent is sine pi over 4 over cosine, right? Tangent is sine over cosine. Sine pi over 4 is this,
2 squared over 2.
right? And then cosine pi over 4 is also this. So that's the reason why tangent of pi over 4 is 1. Yeah? So they all connected. Yeah? Then the next one here is the same thing. The next one right here. The next one right here is the same thing. But instead of positive, now they become negative. So negative 3 over 2, negative 2 of negative square root of 2 over 2, and negative 1 half. Same thing here, but it's still positive, right? Because I'm still up. So square root of 3 over 2, square root of 2 over 2, 1 over 2. And same thing over here. See, they're all connected. What number is this? What number is this? What is the smallest number? The scale will be different because I didn't do it right. But the smallest number is
5 over 3.
what is the smallest number here? I know the scale will look different. That's why.
Oh, 1
So
half.
you have this, and then this. Okay. So negative now become negative. Negative and negative square root of 2 over 2, negative square root of 3 over 2. Okay. Same thing here. Same thing here. Same thing here. Do you remember the sign? All students take calculus. I told you before, right?
Yeah.
A S T C. Now do you know why they're all going to be positive here? Because they're all positive. Cosine and sine positive in this area, in this quadrant. And do you know why this one's only sine positive? Because only sine positive here, cosine is negative. And since cosine is negative, tangent is also negative. Make sense? And do you know why this one is tangent is positive only? Why tangent is positive here?
Because they're both negative.
Because they're both negative. Very good. You get it there. You get that. Very good. Why this one only cosine positive? Because sine is negative. This area here is sine negative, right? So basically, this is the basic. And then you need to figure out what the degree here. Easy. How do you find this? From here to here, pi over 3, right? So pi over 2 plus pi over 3. You get this one. What is pi over 2 plus pi over 3? Oh, wait. No. So this one is symmetric of this, this one is symmetric of this. This one is symmetric of this. The way the scale will be different, but what is this one? What is this one? What is this one? You can also go from 180. It's easier. 180 minus the pi minus pi over 6. You're going to get this one. Pi over 6, right? And then pi minus pi over 4. You're going to get this. 3 pi over 4, right? Pi minus pi over 4. From here, I add to get this. But from here, I subtract to get this. And then pi minus pi over 3, I get this one. Is 2 pi over 3. So they can figure out the rest. Okay. Tell me what is the cosine of pi over 6? Look at the unit circle. Cosine pi over 6. Yeah. Yeah. Cosine. Okay, cosine. Look at this one. Cosine of pi over 6 is square root of 3 over 2. What is sine of pi over 6? 1 over 2. Oh, now you know how to read it. Good. Cosine pi over 4. Square root of 2 over 2. Sine pi over 4. Sine pi over 4. Square root of 2 over 2. Cosine pi over 3. 1 half. Sine pi over 3. Square root of 3 over 2. Good. Cosine pi over 2. 0. Right? Right here. Right here, cosine 0. Right? So 0. And then sine of pi over 2. 1. Yeah? You know how to read unit circle? I think the hard part is to figure out what's the rest of this. But they're all symmetric. Pi minus this, you got this. And how do you get this one? Pi over 6, you have 180. So how do you get this one? Pi over 6 plus 5. Right? Because you add another 180 degree. Right? So 1 pi over 6 plus 5 is 7 pi over 6. So this one is 7 pi over 6. Yeah? And then you're going to add another pi over 4 plus pi. I go 180 degree. Next one is 5 pi over 4. You got this, yeah? Does it make sense? We're gonna have another lesson about this, but just introduction, okay? All right. So when you draw this one, 0, when t equal to 0, 1, 0, 1, 0 is here. When t equal to pi over 6, you get here. So literally, this is just a unit circle right there. They go this way, okay? So remember, why do I show this is a circle? Because remember, this they call polar coordinate. Write it down. This is very important. Polar coordinate versus Cartesian coordinate. Okay, coordinates. So how are you changing this into Cartesian? The other one is easy, right? The other one is easy. The other one you just need to isolate the t and plug into the other one, correct? The second one. Now this one, how do you isolate the t? Are you going to do like arc sine or arc cosine? It's going to be a mess, right? So how do we eliminate the t? So that's the reason why the homework helps. Because the more homework you're working on, you're familiar with different type. And watch this, because we don't have time. Let me show you. What is sine square x plus less than t? What is sine square t plus cosine square t? Equal to, so what to say? 1, right? What is this? What is sine t? What is sine t? Y. So what is this one? Y square. Yeah? Y square plus x square equal to 1. Do you remember this is the circle function? That's not from this. See, not connect the dots. See, that's not from this. That's the circle. And the general, this is unit circle. That's why equals 1. But the general function is x squared plus y squared equal to r squared. Okay, that's the circle. The real circle, like not 1. And the center at. Did you learn the real circle function? Like conic section? Did you learn about conic section? Or the circle, hyperbola, ellipse? No. So the real circle function is this: x minus h squared plus y minus k squared equal to r squared. To be more specific, x and k is going to be your center x and k. Okay. What is the center here? The origin. That's why you don't see anything, right? That's why the center is origin. But when you see some different circle, for example, if you see circles like this, the circle is not the origin anymore, right? They're going to be like 3, 2. Then you're going to have what? X minus 2 square plus y minus 3 square, right? And then let's say if the radius is 4, then equal to 60. Yeah, that's a conic section. Maybe we're going to go to conic section later too. Maybe, I don't know, if this semester or maybe next semester. We have one more example, but
I don't think F1 have.